Welcome to The Explainer. Today, we're diving into the world of some incredible supermaterials that are literally building our future, making it lighter, stronger, and a whole lot faster. And it all really starts with one simple question.
So, have you ever wondered why we don't just build airplanes out of steel? I mean, it's incredibly strong, right? It seems like a no-brainer. Well, the answer to that question gets to the very heart of a massive engineering challenge.
It all comes down to this eternal trade-off. See, for anything that has to move, whether it's a car or a plane, you're constantly in this battle between strength and weight. Steel? Yeah, it's a powerhouse, no doubt, but it is so heavy. Aluminum is a lot lighter, but you end up sacrificing a ton of strength. And then you've got carbon fiber, and it just seems to completely break the rules. It's ridiculously strong and incredibly light. So, how on earth is that possible?
Well, what if you didn't have to choose? What if you could get the best of both worlds? The secret is to make materials work together, as a team. And that is the core idea behind what we call composite materials.
A composite material is pretty much exactly what it sounds like. You take two, or maybe more, totally different materials, each with their own pros and cons, and you combine them. But the result isn't just a simple mix. It's a brand new material with properties that are way, way better than either of the ingredients could ever be on their own. It's a classic case of the whole being so much greater than the sum of its parts.
So how do you make one? It's actually a beautifully simple two-part recipe. First, you've got your reinforcement. These are usually fibers, like carbon or glass, that are incredibly strong, but they can also be a bit brittle. They bring all the muscle, the raw strength and stiffness. And second, you've got the matrix. This is usually a polymer resin, and it basically acts like a high-tech glue. Its job is to hold all those super strong fibers together, give the part its final shape, and protect those fibers from getting damaged.
And that right there, that quote, just perfectly captures the magic of this partnership. The fibers are like the powerful skeleton, but they can snap if you hit them the wrong way. The resin, well, that's the flexible tissue that holds it all together and absorbs the impacts. On their own, they each have a critical weakness, but together, they create something that's both incredibly strong and incredibly tough.
And you know, for all this talk of high-tech polymers and carbon fibers, the basic concept is ancient. I mean, think about steel rebar inside a concrete pillar. Concrete is great when you squeeze it, but it cracks if you try to pull it apart. Steel is the exact opposite. Put them together, and you get modern construction. It's the exact same logic our ancestors used thousands of years ago when they mixed straw into mud to make stronger bricks. This simple but really powerful idea has kicked off a total lightweight revolution. And you probably don't even realize it, but these materials have quietly taken over huge parts of our modern world.
The scale here is just staggering. I mean, look at this. We're not talking about some niche, high-tech toy for the super rich. We're talking about industrial equipment, transportation, construction. Together, that's more than 2/3 of the entire global market. This stuff isn't on the horizon. It's already here. It's everywhere.
So let's do a quick tour, okay? Let's see how these versatile supermaterials are fundamentally changing pretty much everything we build.
Okay, let's start up in the sky. Aerospace is probably the most famous example, right? A modern jetliner like this Airbus A380, more than half of its entire weight is composite materials. That massive reduction in weight is what slashes fuel consumption and, frankly, what makes modern efficient air travel even possible. Now, how about green energy? You see those gigantic wind turbine blades? Some of them are longer than a football field. The only reason they can exist is because of composites. You need a material that is unbelievably strong to handle those wind forces, but also light enough to spin efficiently. There's just no way you could build them out of steel or aluminum. They'd be way too heavy to even move.
Back here on the ground, it's the exact same story. That same principle, incredible strength without the weight, is what makes high-speed trains more efficient, and what gives supercars that jaw-dropping, race-winning performance.
And hey, it's not all heavy industry. It's in the things we do for fun, too. That awesome combination of strength and flexibility is what you feel in a pair of high-performance skis, and is what makes the hull of a yacht strong enough to handle the constant pounding of the waves year after year. Okay, so we've established composites are everywhere. But the story doesn't end there. Not even close. The technology is always moving. And the next generation of making things is all about getting faster, smarter, and a whole lot greener.
To really get what's coming next, you need to know about the two main flavors of that resin we talked about, the matrix. For decades, the standard has been something called a thermoset. The best way to think about it is like baking a cake. Once you cook it, that's it. The change is permanent. They're super strong, but they take hours to make, and they're almost impossible to recycle. The real future, though, that seems to belong to thermoplastics. Think of these more like ice. You can melt them down, reshape them, and let them get hard again, over and over.
So why the big switch? It comes down to two things: speed and scale. Think about it. Aircraft makers have massive backlogs of orders. They just can't afford to wait around for hours while a single part cures inside a giant energy-guzzling oven. They need to build planes way, way faster. And thermoplastics are the answer to that problem. And the advantages here are a total game changer. You're talking about production time crashing from hours down to just minutes. And get this, instead of using thousands of heavy metal bolts, you can literally weld thermoplastic parts together. That saves an incredible amount of weight and time. And crucially, they're fully recyclable. That opens up a true circular economy for these advanced parts. The whole package makes automated, high-speed manufacturing a reality.
So this isn't just a small step up. It's a complete change in how we think about making things. We're moving away from a world of slow, massive, energy-intensive ovens and tons of manual labor, and into a world of fast, precise, automated robotic assembly lines. It's a genuine leap forward.
And that really brings us to the big question, doesn't it? We've seen how these supermaterials are already reshaping our world, making everything from jet planes to wind turbines possible. So as this technology gets even faster, cheaper, and more sustainable, what comes next? What are we going to build when those old-school limits of strength versus weight just don't apply anymore?